This video covers loading data from server. The structure of this video is as follows. Python Simple HTTP Server Revisited. D3 Type Specific Requests Revisited. Loading TSV data from server. And the summary. Alright, let's get started. Python Simple HTTP Server Revisited. The Python programming language comes with many modules in the standard library. There are many wonderful and amazing things built into this library. The one we are going to use is a module that provides a simple web server that we can run on our own computer. The Python module SimpleHTTPServer defines a very simple HTTP server in the directory in which it is run. It maps the directory structure to HTTP requests. Using the command line interface on a computer with Python installed, we can start an HTTP server in any folder we want. When we run the python-m SimpleHTTPServer command, it will start an HTTP server in the folder where the command is run. After we press enter, you can see that the HTTP server starts running. It tells us what IP address it is running on and what port the web server is listening to. It is serving HTTP requests on IP address 0.0.0.0, port 8000. If there is a file in the folder called index.html, then it serves that file. If there is no file in the folder called index.html, then it just returns the directory structure of that folder. This means that to run the D3 examples, the file name for the example file will be index.html as long as we use the Python Simple HTTP server. D3 Type Specific Requests Revisited. This is the D3 XHR module. It creates an asynchronous request for the URL passed into it. It has an option to take in a MIME type and a callback JavaScript function. The XHR call will invoke the callback function with two arguments, the error and the data. The error, if it exists, is the error for why the request failed. The data is the actual XML HTTP request object. If an error occurred, then the data XML HTTP request object will be undefined. It is here within the callback function that the D3 work that we have been building up to takes place. D3 has type-specific XHR functionality to load in data into the browser from a server. This functionality covers text data, JSON data, XML data, HTML data, comma-separated values data, also called CSV, and tab-separated values data, also called TSV. Each type of request has a certain feature and method for parsing the data that come in. The D3 type-specific request creates a request for a specific MIME type file at the specified URL. The D3 type-specific request call will either result in the resources being loaded or the request will fail. The D3 type-specific request call will invoke the callback function with two arguments, the error and the data. The error, if it exists, is the error for why the request failed, and data will be undefined. If no error, then the data will contain the response. Depending on the MIME type, the response will be parsed any number of ways to make it incredibly easy for us to use the data in D3. For now, the two most common MIME type D3 type specific requests that we will use are the CSV and TSV. The difference in the two file types is just the delimiter between values. It is either a comma or a tab. The D3 CSV and TSV type specific requests create a request for a CSV or TSV file at the specified URL. The D3 type specific request call will either result in the resources being loaded or the request will fail. The D3 type specific request call will invoke the callback function with two arguments, the error and the data. The error, if it exists, is the error for why the request failed, and the data will be undefined. If no error, then the data will contain an array of parsed rows from the CSV or TSV file. This is what it means when D3 takes in a CSV or TSV file and parses it into an array of parsed rows. Each array item is a JavaScript object where everything, even numbers, are strings. By parsing it in this way, you can use everything we've learned about arrays of JavaScript objects to use the D3.data functionality. D3 does the exact same thing as seen on the screen with the TSV data files. We will focus on TSV files for now, as that is what most of the D3.js.org examples use. The CSV files work the same way It is just that the delimiter is a comma instead of a tab. Loading TSV data from server. We will use the TSV data from the D3.js.org website scatterplot example. We will save this data into a file called data.tsv. This file will be located in the folder where we will run the Python SimpleHTTPServer command. This file is the one that will be loaded asynchronously using the D3.tsv request functionality. This is how we are going to call the D3.tsv request. The data.tsv part of the D3.tsv call is the URL we're calling. Because we are using the Python SimpleHTTPServer, which serves files from the same directory as the root URL, this will look for the data.tsv file in the folder we are in. The callback function of the D3.tsv call is the anonymous function highlighted. It takes in two parameters, the error and the data. In this case, we are going to assign the error and data variables to a callback error variable and a callback data variable. Note that we define the callback error and callback data variables outside of the function. This is so that we can read the variables once the D3.tsv function has returned and loaded the data. Let's move to the JavaScript console now. We start at the D3.js.org website scatterplot example. We scroll down the page until we come to the data.tsv headline. This is the data we want to copy to put into the data.tsv file. Notice that there are 5 headings, and each row contains 5 columns. The first 4 columns are numbers, and the last column is a word. We highlight all of the data under the data.tsv heading. We copy this data. We open a new text editor file, and we paste the data into this file. Now we save this text file in the folder where we are going to run the Python SimpleHTTPServer. Note that this folder already contains the index.html file we will use. If we take a look at the folder, we see 3 files. The d3.js minified file, the index.html file, and the data.tsv file. Next, let's open the command line interface and navigate to the correct folder. It is in this folder that we will run the Python SimpleHTTPServer. Let's start the Python SimpleHTTPServer. We have started the HTTP server. You can see the message serving HTTP on 0.0.0.0 port 8000. Let's go to the web browser and go to that address. It is working and you can see the text that I had written earlier in the index.html file. Let's go to that index.html file in the text editor and add some D3 to it to load the data. We write the callback error and callback data variables. Then we write the d3.tsv request. We tell it what file to get. We then provide an anonymous callback function that receives 2 arguments, the error and data. Inside of the function, we assign the error to the callback error variable. We also assign the data to the callback data variable. Lastly, we generate an alert to tell us the data file has been loaded. Let's go back to the browser to reload the file. From the alert, we can tell that the JavaScript callback function from the d3.tsv request was run. Now let's open up the Chrome Developer Tools to check to see what the error and data variables were assigned. You can see that the callback error is null. This means no error was encountered. You can also see that the callback data is an array of 150 elements. Let's look at the first element. D3.tsv parsed the data for us and created 150 objects for each of the 150 rows of data in the data.tsv file. The first object has the sepal length, sepal width, petal length, petal width, and the species. This is fantastic. D3 took in the data file and parsed it into JavaScript objects for us. We can now pass this array into the d3.data functionality and it will work seamlessly. Let's do one last thing. Let's change the file name of the data.tsv file from data.tsv to data1.tsv. Then let's reload the browser. We get the alert so we know that the d3.tsv functionality ran and called the callback function. In the JavaScript console, we can see an error occurred with the HTTP GET command. Let's look at the two variables and what values they were assigned. First, we see that the callback error is no longer null. It contains an XML HTTP request object that describes in great detail what the error is that occurred. When we check the callback data variable, we see that it is undefined. This is expected because when the D3.tsv functionality encounters an error, it will make the data argument undefined. Note that the D3's type-specific requests all work almost identically. The only difference will be how the data that gets returned is parsed. And with that, we have covered, tested, and experimented with loading data from the server using D3.js. The summary. This video covered Python SimpleHTTPServer revisited, D3 type-specific requests revisited, loading TSV data from server, and the summary.